All right, friends, welcome to class. We are covering the integumentary system tonight. So before we roll into this too deeply, I do just kind of want to open up the floor for like questions and comments. How did you guys feel about respiratory system last week? Feeling confident? Feeling not so confident? Anything in particular we wanted to cover from last week? Anything in particular we wanted to review or chat about? Okay, well, if you come up with something, just shoot me an email. I'll be happy to talk you through it. All right, guys, so we are going to get started with integumentary system. Integumentary system, as we know, is the system of the skin. So first things first, we'll talk about the functions of the integumentary system. And the skin actually performs a lot of functions. First would be protection. It protects us through a variety of ways. Number one, it provides a chemical barrier. And this is done through the slight acidity of the skin. When we measure its pH, skin is usually somewhere around 4.7 to 4.5, which is slightly acidic. We have UV protection. So the melanocytes in your skin produce melanin, that's your skin pigmentation. And the more melanin you have, the more protected you are from the harsh UV rays of the sun. The skin will also produce antibacterial secretions, generally in the sebum, which is the oil. And those just kind of control the amount and the kind of bacteria that we find on the skin. Now, probably the most important function of the skin is its role as a physical barrier. So one of the best ways of keeping things out is to have a physical barrier that differentiates what is inside the body from what is outside the body. And that's what the skin does. It keeps out bacteria and toxins, and it holds in water. Because if we didn't have skin, we would lose so much water through evaporation, and just your body would just desiccate. It also provides biological barriers, generally the presence of your phagocytic cells. So in the event that the skin does get breached, there's plenty of white blood cells just below the surface of the skin, so that any bad guys or pathogens that enter the body will quickly be yeah, it's tough life being a cell. Continuing in the functions of the skin, skin functions to maintain our body temperature. This, with the skin, we're talking about things like sweat. So the ability to sweat goes a long way in terms of keeping humans cool. And sweating really is kind of a unique human trait. There are very few other animals in the animal kingdom that developed this cool trick. So if you look at man's best friend, for example, dogs do not have sweat glands, only in like their paws, like in between their little fingers and their little paw pads, they have a little bit of sweat glands. Other than that, they don't sweat. So the way that dogs offload all of their excess heat is through panting. All of the blood vessels in their mouth and tongue, they open the mouth, exposing it to air. They breathe very rapidly, cooling all of those blood vessels and cooling the blood that is then circulated throughout the body. Humans, on the other hand, sweat. And to understand how sweat functions, you need only to have taken a shower. And you snatch open that shower curtain and suddenly, it's really cold in that bathroom. So you dry off really quick. As the water starts to evaporate off the skin, it pulls a little bit of heat with it. So as the water evaporates, or as the sweat evaporates, it leaves the skin just a few degrees cooler. That in turn cools the blood, which then gets recirculated, cooling the temperature of the body overall. So the ability to sweat is key to our ability to regulate our own body temperature. Skin is also the largest sensory organ that you have, so it is constantly looking for changes in the environment. These would be temperature changes, these could be pressure changes, these could be any kind of change related to touch or vibration. The skin also initiates vitamin D synthesis. So vitamin D synthesis begins in the skin, and it's triggered by sun exposure. So when we talk about, ways to get vitamin D, one of the easier answers is vitamin D milk, of course. But the thing is, milk isn't really a good source of vitamin D. We put the vitamin D into the milk. It has been fortified with vitamin D. To develop or to stimulate vitamin D production naturally, you need only get about 10 to 15 minutes of direct sun exposure on your skin. After about 15 minutes, your body will start producing vitamin D on its own. Now, here is where I like to take a quick pause and just talk for a moment about why vitamin D is so important. Can anyone tell me what the role of vitamin D is in the body? One of its primary roles. Okay, so we know that we drink milk for strong bones, right? We've all heard that thing, milk for strong bones. And we also know that milk has high amounts of vitamin D. Vitamin D is required for the chemical process that binds calcium to the bones. So without vitamin D, you can consume calcium, but we can't bind the calcium into the bone matrix without vitamin D as a precursor. That is why vitamin D is important. Yes, you need the calcium to build strong bones, but just like a brick also needs a mortar, you need vitamin D to bind the calcium to the bone matrix. That is why vitamin D is so critical. The skin also serves as a repository for nutrients. The skin will store various nutrients like water and oxygen, particular blood nutrients, metabolic products, fat. So the subcutaneous fat, right? That fat that sticks under the skin. That's when you get like the underarm wobble or like the little turkey wobble. The skin is storing adipose tissue to make sure that we have ready energy sources really close and available if the tissues ever need them. The skin also serves as a reservoir for blood. So if you have, a little bit of extra blood, where is it going to go? It's going to get stored in the skin. At any given time, your skin is holding about 8 to 10% of the total blood volume. So all the blood in the body at any given time, 10% of it is in the skin. Another huge portion of the blood is in the brain at any given time, and an even larger portion of the blood is in skeletal muscle at any given time. So all the rest of your organs, right? Like the blood that's going to the heart, like in the heart itself, not the pumped blood, but like the coronary blood that the heart is using for its own function, and the blood that goes to the lungs for the lung function, and the liver and all the other organs. Those are just a small portion. Like your normal organ blood usage is just a small portion of your overall blood volume. The vast majority of your blood is being used in the brain and the skeletal muscles, and to a larger extent, the skin. The final function is its excretory function. The excretory system is all about getting waste products out of the body. So we naturally think about the bowels when we think about excretory system, right, and getting waste out. But there are other places that we look, like lungs, which are excreting carbon dioxide, and the skin, which is excreting water, salt, and a small amount of metabolic waste. The excretory function here, guys, we'll come out and say it. It is a thin little function, but it counts. By far, most of your excretory functions are being handled by your large intestine and the lungs, but the skin does count. So the skin is comprised of 3 layers, and the most interesting one is the one right in the middle, the ice cream of the ice cream sandwich. It is called the dermis. The dermis is the true skin. That is where all the living stuff is. That's where all the fancy stuff lives. That's where all the really important stuff exists. This is the layer that is made of connective tissue. This is where all of the blood vessels are. This is where your nerve endings exist. This is where the sweat gland is. This is where the hair follicle sits. Now, the next important layer is the layer on top, the epidermis. Anytime you see that prefix, epi, E-P-I, Your textbooks and medical dictionaries will always translate that word part for you as above. My experience, I'm here to tell you guys, above is not the best translation for that word part. The better way to understand the word epi is upon. Much more accurate word. The dermis is the middle layer. The epidermis is upon the dermis. And the reason that that distinction is important is, I mean, think about a shoulder, right? You have the dermis and then you have the epidermis. If it meant above, then you're thinking about something above the shoulder. But if it is upon the shoulder, it will be over the whole thing. And that's exactly what we see with the epidermis. At no point is raw dermis exposed to the outside world. It's always covered with epidermis, except when you're injured. Injuries don't count. Now, epidermis sits on top, dermis sits in the middle. The bottom layer is called the hypodermis, or the below dermis layer. This is the subcutaneous layer, and it is characterized by the presence of adipose tissue. This is where all the fat in the skin lives, in the basement layer. Its function is as an energy reservoir. That is what fat is. It is energy, just converted into a shelf-stable form that we can store for a really long time. It also serves as insulation. As anyone will attest who's ever lost weight, you lose a bunch of weight and suddenly, dude, everywhere is a lot colder than it used to be. You had a lot more insulation packed on before you lost those 30 pounds. And lastly, shock absorption. It's squishy, it's cushiony, and it helps diffuse the force of impacts. So before we move into the cells of the epidermis, I just want to take a moment and pull up our anatomy app, because it really does have a fantastic illustration of the cross section of the skin. All right. So, broad overview, just to get ourselves oriented before I start zooming and picking and turning this thing all around. We'll zoom in just a little bit. The dermis is the white layer. The hypodermis is the yellow layer at the bottom. And the epidermis is that thin little pillow top mattress that's being peeled off the top. So epidermis, dermis, hypodermis. The dermis, as we said, is the true skin. That's where all the really important stuff is. So that's where we are going to begin our journey. And I think I'm just going to zoom in and just kind of like carry us from right to left. And we'll just kind of encounter what we encounter as we, you know, magic school bus style our way through the skin. So here, starting in the dermis, we see lots of little squiggly lines. Reds are arteries, blues are veins, yellows are nerves, greens are lymph vessels. So notice that you always will have lymph vessels hanging out right close to the blood vessels. This is what we mean when we say lymphatic vessels are associated with the circulatory system. We mean the two happen together, they occur together. So anywhere you've got capillary beds, you're also going to have kind of intertwangling around those lymphatic vessels, absorbing all of the blood plasma that gets pushed out of the blood vessel. The larger kind of bulbous thing that you see here, that would be your hair follicle. We'll get a cross section, but on the outside that just look like bumpy little lumps. But the other thing that I want to pull your attention to are the little broccoli things that are sticking off the sides of it. Those are sebaceous glands. Those are sebum glands. They produce the oil. So if you've ever gone a couple of days without washing your face and your skin gets really oily, that's them. They are associated with hair follicles. So let's translate this again. Sebaceous glands are associated with hair follicles, meaning They happen near hair follicles. They happen together. That's what we mean. You'll also notice that attached to the hair follicle is a tiny little muscle. These guys are just a couple of millimeters long. They are tiny. These are called arrector pili muscle. Arrector starts with an A, not an E. Arrector pili. This, you are seeing the muscle in its relaxed state. When it contracts, when it gets stimulated to contract, the bottom side pulls up towards the top side. So the entire hair follicle is raised up towards the surface of the skin. That's a goosebump. Each hair follicle has an associated arrector pili muscle. So when they get stimulated, all these muscles contract together and all the hair stands up. That's a goosebump. That's what these guys do. Now, for us hairless apes, goosebumps really just kind of give away our emotions, right? They give away that you're scared or they give away that you're cold, but they don't really function to do anything anymore. But way back in the day when we had lots and lots more fur, like our ape cousins, goosebumps serve to raise the hairs a little bit, and it gives you a little pocket of air held to this close to the skin that's held in place by the hair, and your body heat will warm that air. Goosebumps serve to insulate you. The other thing goosebumps serve to do, particularly when they happen when you get afraid, you ever seen a dog get really scared or a cat and suddenly all their hair stands up on end and they use that to make themselves appear much larger to whatever is threatening them? That's same thing, right? You say, oh, I got scared and I felt the hair stand up on the back of my neck. Well, when your hair is that long, big whoop, you felt scared. But when you have fur that is much longer, suddenly all that fur standing up on end might make you appear much more intimidating to whatever it is that is scaring you. So goosebumps serve in the animal kingdom as a defensive mechanism and as a way of maintaining body temperature. In humans, they just show that you are cold. Sorry. Another important structure that we see here, you're looking for at the end of the yellow nerves, these little bulb-like structures, like this guy here highlighted in pink, or this guy over here now highlighted in pink. These are various nerve endings. So literally, the end of a nerve. This nerve is traveled all the way from the brain or from the spinal cord. It's finally reached its destination somewhere out in the skin, and that nerve ending terminates in some kind of bulbous apparatus like these, and these are very specialized as to what they are detecting. There are certain ones that detect deep pressure. There are others that detect light pressure, so like a caress. There are some that detect vibration. There are others that detect heat or cold. My point is, they're very specialized. So, moving on, the next cool thing we see is this guy. This little green coiled up little thing, that is a sweat gland. So sweat is produced down in that bottom coiled part, which interestingly enough is called the fundus. So sweat is produced in the fundus, and then it is transported along the vessel, again, to an associated hair follicle. So sweat and oil glands are producing their stuff in between the hair itself and the wrapping of skin that's holding the hair in place. So then, as those fluids are pushed in around the hair, they rise up the hair and then spill out over the skin. That's how oil and sweat get in. They ride up the hair follicle and then spill out of the pore that the hair is growing out of. Now, this moves us into our beautiful little cross section of a hair. So here in green, that is the cortex of the hair. And that's, for all intents and purposes, that's the hair. That's what you see when you're looking at the hair. If I zoom in a little more, you might get the cuticle. Now, that is actually what you see. So whatever has the color of your hair, or if you're going gray like me, it's the cuticle that is lacking pigmentation. That's where the color of the hair comes into play. So the cuticle is the hair as far as what we actually see when we look at the hair. We can ride this up and turn this around, and we'll realize that's a hair. That's the cuticle. That's the part that you see. Whoa, that was way too fast. Sorry. But when we zoom in, you see the cuticle is just the outer layer. There's like more to the hair that's going on. The cortex is the central portion. And then right in the center, you have the medulla. And there we have that pair of words that we see over and over again, cortex and medulla. And as always, the medulla is in the middle. The cortex is the wrapping around the medulla. Here we have the inside portion, or inside look at the sebaceous glands. These are producing sebum, which is oil, normal skin oil. You can also see a little bit of sebum being secreted, pressed between the gland and the hair itself. I'll highlight those there. That's the oil. So as the oil is produced, it will get pushed up along the hair follicle until, as I said, it will spill out and then spread across the surface of the skin. This is another hair follicle. So again, we have associated sweat glands, associated sebaceous glands, and associated erector pili muscle. And at the bottom, you will notice the hair is getting its own blood supply. This is why, ladies, ever had your eyebrows tweezed? Yeah, ever gotten a little pinprick bleeding? Or maybe we've been waxed, and after you get waxed, you get the little pinprick bleeding. This is why, because the living hair is plugged into the circulatory system. So when you snatch a hair out, all those blood vessels get ripped out as well, and you get a little bit of bleeding. Bright side, those blood vessels are tiny. So when you rip out the hair, the resultant bleeding is just pinprick, just a little dot blood. All right, that covers most of the major structures that we find in the dermis. Next, we're going to look up and take a look at the epidermis. So here you'll see there's this kind of sawtooth division between the two. This is structurally accurate. Each of those cone-like projections is called a papilla, plural papillae. Just add an E to the end of the word. Papilla, papillae. These papillae extend into the dermis, whereas the dermis also has papillae that extend up into the epidermis. You get these little sawtooth-like deals. They stick together. They adhere to each other. It holds the skin, or it holds the epidermis onto the dermis. So you really do get this really cool, like memory foam, pillow topper type interaction between these two layers. But next, we start looking at the skin a little closer and we realize the epidermis is a bunch of layers, just a whole bunch of layers. So ugh, did my pencil die? I'm sorry, guys. I think my Apple Pencil may have died. I need to check its battery. Come on. Lord. Ah, it just didn't connect. Okay. Sorry for the technical difficulty. Ah, much better. Okay. So, to understand the layers of the epidermis, despite how thin the epidermis is in relation to the dermis, there are 5 layers to this uppermost layer of the skin. And the way that I like to keep them straight we start at the bottom and we name as we go up. So starting from the bottom. George spit gravy in Lucy's corn. I didn't make it up. I'm just telling you how to learn it. Okay, so each layer of the epidermis is known as a stratum. Stratum is just a fancy word. It means layer. That's all. So the epidermis, we've seen already, all the living stuff in the skin is down below in the dermis. That's where the blood is, that's where the nutrients are. So all the cool stuff is down below. So the bottommost layer of the epidermis, this stratum germinativum, this is the baby layer. This is the layer that is actively reproducing. When cells reproduce, we know they kind of cleave and they divide into two identical cells. Baby cells are pushed down. So the old cells ride up. So each layer that we go up in the epidermis, the cells are getting older and older and older. By the time you get to the very top, they're dead. So I'll add on here younger to older. The stratum germinativum, the names are all telling you something about what's happening. This root to germ or germinate, like a plant, right? Germinating, it's budding, it's seeding, it is sprouting, it is reproducing. Stratum germinativum is the layer that is reproducing. This is the layer that's producing new baby skin cells. When we produce a baby, the baby comes out and gets pushed down. The mother cell gets pushed up into the next layer. We're starting to get a little bit older. And we know that we start to get a little older, we start to get a little more cranky. This is the spiny layer because the cells are starting to develop little spines. It's just because of the way they look. After you pass through the spiny layer, we reach stratum granulosum, as I like to call it, the granny layer. The granny layer. The cells are getting old. White-haired, big glasses, Sophia Petrillo style. They're becoming grannies. By the time we get to stratum lucidum, most of these cells are right at the end of their lives. When people get really old, they start kind of losing their mind. Stratum lucidum. The word lucid means clear, like lucid dreaming, or the white hair of really old people. This is the final layer that cells will be alive. The cells will die in stratum lucidum. Once they have died, their dead husks will keratinize. All the moisture and all the extra protein and all that stuff, your body reabsorbs all that. You ain't just tossed out the body with valuable water and protein in your cell membrane. Oh, no. We're sucking you dry. All the useful protein, all the useful elements, all the useful water, all of that stuff gets extracted from this dead husk of a cell. Its deflated membrane will keratinize. So instead of being a loose, floppy, empty balloon, it becomes hard and keratinized. It turns more into like a scale or a flake. And then it gets pushed up into the final stratum corneum, the corny layer. No, I'm kidding. The corneum is the one you see when you look at your skin. That's the one. Scratch your skin with a fingernail and then look at it closely. Notice how the skin turned a little bit ashy where you scratch it, you have disrupted the stratum corneum. You have not yet broken through to the stratum lucidum. Okay. Stratum corneum, as more cells keep getting pushed up and up, the cells on the very, very top of the stratum corneum will detach and flake away. That is dust. That's all the dust in your house. All your skin, just all the skin cells that you shed throughout a day or a month or a year, that's where they are. The topmost layer of the stratum corneum. Now, the mnemonic device that I recommend the most is this one here. George spit gravy in Lucy's corn. It takes us right through the layers of the skin from the living layer to the dead layer. However, some people prefer to start at the top. Sorry, that's the wrong one. Some people prefer to start at the top. So we say germinativum, George. Okay, stratum germinativum, since it's at the bottom, welcome to anatomy, everything has 5 different names. We all just have to die mad about it. Stratum germinativum also goes by the name the basal layer. What we're getting at with that word is it's the base or the basement. It's the bottom layer. That's what basal is telling you. It's the bottom one. Germinativum and basal, stratum basale, are interchangeable. So some people prefer to do their mnemonic device from the top down. I do have one for you. It is come, let's get sunburned. Corneum, lucidum, granulosum, spinosum, basal layer. I know, it's not as funny. It's not as funny. Personally, this one is my favorite. That's the one that sticks in my head, and whenever I'm thinking about the skin, that my head goes straight to George spit gravy and Lucy's corn. So the best mnemonic device will always be the one that you remember. So whichever one of these is the stickiest, whichever one sticks in your brain the best, forget all the other ones, use that one. But we are naming the same thing here. All we've done is just named them from the top to bottom or from the bottom to the top. That's it. Good stuff? Okay, so we can't even see all of these layers really in this illustration. What I will say is you do have the 4 layers going on. Those are the ones where you see all the cells. But then this layer up top, notice there's a really good. You've got cells. Those little spots down below, those are nuclei. So you've got all of these rows of cells until you get to this green layer, and then suddenly no cells. That is the stratum corneum. That is all dead. All those cells are dead, and their bodies are desiccated, and their round cell membranes have become flat roofing scales layered on top of each other. And every time you brush against something or scratch something, that is the layer that is being removed. Fun stuff. Oh, another cool detail, when we look straight down at the surface of the skin, that's sweat you're seeing on there. Those little like blue dot, that's sweat. Man, you didn't realize how intense the skin was, right? You didn't realize how much was going on in there. So this brings us down to the final layer, the subcutaneous layer, or the hypodermis. It's this entire layer here in yellow. The yellow is adipose tissue, that's fat. We can see the larger blood vessels, so our lymphatic trunks, our venules, our arterioles. The smaller blood vessels are down there. Capillaries are up here. Arterioles and venules would be down here. And this layer is rather unremarkable. Nothing is going on here that you haven't already seen, save for a few select nerve endings, like a lamellar corpuscle. They are sensitive to pressure, touch, vibration. Usually the ones that are sensitive to deeper pressure are found deeper because it takes more pressure to stimulate them. Make sense? If it's supposed to detect deep pressure, you don't want it sitting right on top because everything that touches it is going to activate it, right? That is where you want light touch receptors. So a light touch will turn them off. What you want is your deep pressure receptors deeper in the skin. So it takes more pressure to activate them. Cool. So there's our basic tour of the skin and what's going on. Everybody comfortable so far? Any questions or concerns? Right on. All right, well then away we go. Next thing we're going to look at are cells of the epidermis. And most of the cells are going to be keratinocytes. The ending cyte, C-Y-T-E, means cell. So anytime you see some word ending in cyte, what the word is telling you is, I'm that kind of cell. Sorry, hold on. Screen recording has stopped due to... Okay. Sorry, Zoom told me it stopped recording for a second. I had to figure that out. I'm sorry. Okay, keratinocytes. Whenever you see a word ending in cyte, what it's telling you is, I am this kind of cell. So a keratinocyte is a keratin cell. These are cells that produce keratin. Keratin is a protein, and it is the chief protein found in hair, skin, and nails. Keratin can be arranged in two different forms. One is a long strand type protein. 3 guesses where you find those. And the other is a flat scale type of arrangement. 10 guesses where you find those. You see where we're going with this? So keratinocytes are 90% of your skin cells. By and large, if you throw a dart at a board to pick a skin cell, you probably landed on a keratinocyte. They are made in the deepest layer of the epidermis before migrating to the surface. That's the epidermis, guys. That's the whole story I just talked to you about. That's them. They reproduce at the bottom layer of the epidermis, and as they age, they keep getting shifted up, right? Because this made a new layer, and then that baby made a new layer, and then that baby made a new layer. So after a few generations, you are living your life. I'm getting gray. Oh, my joints aren't so supple, and then you die. And now you are outer layer of skin. And then you flake away, and you're just dust in the wind. Next are melanocytes. Melanocytes are cells that produce what? Alyssa Milano. Oh, of course, I'm kidding. Melanin. This is the pigmentation. So the melanin production of your cells is genetically determined. There is no real way to change the baseline. You can temporarily increase the amount of melanin production. That is called tanning, like suntan. But the baseline melanin production is genetically determined. So if you go to the tanning bed, you can get darker, but if you stop going to the tanning bed, you will never get lighter than your base complexion. Melanin is produced, I want to say, if I'm not mistaken, I want to say it's stratum spinosum. I feel like that's right. Stratum spinosum, I feel, is the layer that gives you a skin color. I
We can't see the slides anymore, or I can't.
Oh my.
It stopped when I think that recording popped up.
I think you're right.
Thank you.
Thank you. No, thank you. Thank you for pointing that out to me. Okay. Melanocytes. They produce melanin. That is pigment. The less melanin you have, the paler you are. The more melanin you have, the darker you are. And this brings me into a point that I usually go on a whole rant about, because remember, guys, my background is in anthropology, so like studying humans is kind of my thing. Does anybody know why we have different skin tones?
Kind of depends on where you live. Doesn't it depend on where you live? Like some people live where there's more sun, other people live in other places.
So on the shorthand, yes, you're right. But it's not just about where you live. It's about where your ancestors evolved over long periods of time, right? So you can't just take someone who lives in Africa and move them to Poland and then they have a white kid. That's not how this works. What we mean is people who have darker skin tones had ancestors who lived in equatorial regions or regions that got a lot of intense sunlight. So their skin had to develop a lot of pigmentation to block out all of that excess radiation. People who lived closer to the poles, where the sunlight doesn't hit as directly, it hits more at an angle, they get much less sunlight. So they needed less pigmentation so they could take in that sunlight and produce vitamin D. Remember, you got to make vitamin D through sunlight. So you don't want to block out all sunlight because now you're vitamin D deficient and your skeleton suffers as a result. So a cool way to see this in practice is to look at skin tones based on geographic distribution. And this is what we see. Areas in Central Africa and in the Aboriginal, like the outback of Australia, that is where sunlight hits with the most direct impact, meaning that sunlight is stronger there than anywhere else. Therefore, people who evolved there developed the darkest skin to give them the most protection. As you step away from the equator, the skin tones get progressively lighter. Now, the exception to this would be South America. I remind you guys, South America is mostly jungle, which means there's shade. Africa is mostly desert or savanna, not as much shade. That's why. So the closer to the equator you get, the darker the skin tone you get. The further from the equator, the lighter the skin tone. Now, this made perfect sense and worked beautifully until everyone started moving all over the globe, right? We had a slave trade that was forcing people to move from place to place. Now we have a global economy where people can choose to move from place to place or vacation from place to place. And who knows, you know, you meet a hottie on vacation, you might marry him and bring him home and you make some lovely vacation babies. What I'm getting at here is this pattern has been disrupted over the course of recent human history. Between the global slave trade and globalization, this doesn't really apply anymore. This is an historical context to explain why we have all these different skin tones. Good stuff. Good stuff. All right. Where am I? Oh, that's right. Okay, melanocytes produce melanin. Cell bodies in the deepest layer of the epidermis. Oh, so I was mistaken then. In the deepest layer of the epidermis, that would be stratum germinativum or stratum basal, the basal layer. They use basal on this image on the right-hand side down at the bottom. Stratum basal, that's the basal layer, that's the bottom. Merkel cells. Merkel cells are sensory receptors for touch. They are found in the deepest layer of the epidermis, but don't let that one confuse you guys. The epidermis is super, super thin. super thin. So those would still be like light touch receptors or vibration receptors. And then Langerhans cells are fixed macrophages. These are white blood cells that do not move around. They stay in one place. So these guys hang out, and they any kind of disruption in the skin, meaning a tear or an abrasion or a cut, we have white blood cells that are planted in place. So if a cut happens near one, he is there available to help protect against infection. Oh, also one more thing, if I can just kind of pull our attention to this. That story that I told us about the epidermis, look at the basal layer, right? You see how tall and like plump those cells are? But as you move up a layer, suddenly they're like more cramped, and those edges are a lot more pointy. That's the spiny layer. And then we move up, and the cells start to take on this kind of grainy appearance. That's the granny layer. And then we end up with these flattened but clear cells because we are pulling all the nutrients out as it dies, right? So they kind of flatten, and all that's left is a little bit of cytoplasm and maybe a few bits here and there. So it's just fluid. It's just an empty cell membrane full of fluid. It's a clear layer, right? And then when we get to stratum corneum, they're dead. They're flattened, they're dehydrated, they're keratinized. Nothing special going on. Incidentally, anyone ever gotten a tattoo before? Anyone have a tattoo? The ink from the tattoo is deposited into the dermis. It goes completely through the epidermis. So just a little bit of skin geography there. All right, everything I have just explained to you, we're going to rehash it right here. So we start with stratum basale, the germinating layer, also known as stratum germinativum. This is the deepest layer. It is a single layer of cells attached to the basement membrane. It is the site of keratinocyte formation, meaning that's where skin grows. That's where all your new skin comes from. Merkel and melanocytes are found here. Next, we have stratum spinosum, the spiny layer. This is above stratum basale, 6 to 8 cells thick, mostly keratinocytes. Moving on up, we get to stratum granulosa, the granular layer. I call it the granny layer. Above stratum spinosum, 3 to 5 layers thick, keratinocytes starting to flatten out and fill with keratin. They secrete a waterproof fluid. Waterproof fluid. Feels like we're heading in a certain direction. Next, we get to stratum lucidum, the clear layer. That is what the word lucid means. It is a thin layer, very important on the soles of the feet and the palms of the hands. That is where this layer is thickest. That is also why there's very little pigmentation. Stratum corneum, corneum, I know everybody laugh, get it out of your system. It is called the horny layer because it's like it has horns because they're so flat and like peeled up like little horns. I didn't make up the words, guys. I'm just reporting the news. The stratum corneum, this is a very thick layer. We're talking about 20 to 30 cells thick, made of dead keratinocytes. They are all dead. Now, moving below the epidermis, now we are in the dermis. This is comprised of loose connective tissue, blood, lymph capillaries, sensory receptors, hair follicles, oil and sweat glands. All of these exist here. This is the true skin. The dermal papillae extend into the epidermis. That is just the corrugated thing that we looked at a moment ago. These, the dermal papillae. All the slide is saying is those mesh with those. That's the whole thing the slide just said. Dermal papillae extend into the epidermis. They lock together like that. The dermis is the primary source of nutrients and waste disposal for the epidermis. Notice, guys, the epidermis did not get blood supply. It did not get lymph. It did not get any kind of support. All of its support comes from the dermis. That's why the dermis is the true skin. The epidermis is just a freaking freeloader, man. Collagen fibers are bundled into patterns. Separation between the bundles form lines of cleavage called Langer's lines. Okay, take a look here. When I tap on the dermis, the whole dermis turns green. What I'm telling you is, when I touch off of this thing, the green is going to go back to white. Only the green is what I'm talking about. No other structures. Actually, I can't. Look at that texture. You see those lines and wrinkles? That's what we're talking about here. That's what we're talking about. Just these kind of lines that kind of go all, woo. Lines of cleavage. So these Langer's lines, oh, I don't even know what this is. Langer's line, this looks almost like dermatomes. All right, you know what? Let's learn together. Because that's not what I thought we were talking about. Langer's lines. And how are these different from dermatomes? Langer's lines are frequent mentions in surgeon of the direction. These lines are reported to be ideal for skin incisions in order to minimal tension across the wound. And it results in scars fades amongst the natural creases on a patient's face. Okay. It makes a lot more sense. Did I read that too fast? Did everybody follow me? So Langer's lines, especially important for surgeons, they are showing you where your incision can go, where it will least interrupt the tension on the skin. So look at this little model here and think about where your C-section scar goes. It goes along the Langer's line. Anyone ever had a facelift before? No, you're all too young. Working in skincare, you see a lot of people that have facelifts, and not to be too gross, but when they do a facelift, they have to make incisions. They cut all along the hairline, they go in front of the ears and then down. They peel the skin of the face off, they pull it back tighter, and then suture it and cut off the excess. So they literally peel off the face, pull it on tighter, and then sew it in place. And when they do those cuts, those incisions, they follow these lines. They go along the hairline and they go behind the ear, or in front of the ear, and they come down along the jawline. So when they pull it tight and suture it, you don't want scars cut across the Langer's line because those scars don't heal beautifully. And when you're talking about scarring on someone, you want it to heal beautifully. Yes, you do. Yes, you do. True story. I cannot imagine Langer's lines are that important to massage therapists. Honestly, when I saw this diagram, the first thing I thought about was dermatomes. That's a nervous system thing. You'll talk about those in nervous system. And even they are that important. What do you know? Dermatomes. Okay. Now that I've said the word dermatome 17 times, I will explain to you guys what dermatomes are. A couple of things I want to point out, though, really quickly. Number one, dermatomes are more about the nervous system than they are the skin. Second thing is, it is so easy to overthink and overestimate dermatomes. They are not that complicated. They are not that important. Okay. Here is what a dermatome is. All right. There is your nervous system. The brain and spinal cord have nerves that go to every structure in the body. There's nerves that go to every organ, every individual muscle. Remember all those erector pili muscles we saw? Each individual muscle gets at least one nerve. Some muscles get more than one. Big muscles like pecs and deltoids will get multiple nerves that go into them. Every organ gets nerve endings plugged into it. Skin is an organ. So the question is, which of these nerve endings is innervating a particular section of skin? And the answer quite simply, has to do with that's what a dermatome is. So based on where the nerve segment exits the spine, and you'll see just like spinal segments, right? C4, T1, T12, L2, where the nerve is exiting the spine, that nerve will go on to innervate some bit of skin. We can actually identify exactly what nerve is innervating some section of skin because they are arranged in this pattern called dermatomes. The general pattern, as you see on the torso, they are stripes going horizontally across. So you have all of each of those individual stripes. On the limbs, the pattern is more longitudinal. So you don't get a band across the arm, you get a strip down the arm. Through the torso, you get stacked bands. And then the face is weird because the face doesn't get spinal nerves. The face is innervated by cranial nerves. Subtle, but they're different. So cranial nerves are numbered on their own. We'll talk about it when you get to nervous system. Not important for us today, talking about skin. Here is the point. Dermatomes, people get all twisted up in knots about these things. First of all, they're not that important. Second of all, it's just an area of skin. That's all we're really talking about here, is what nerve is innervating some area of skin. You tell by looking at the dermatome. So, dermatomes are specific spinal nerve segments that will supply innervation to a particular body region, particularly regarding sensory nerves. Good stuff? Cool. So why do massage therapists learn about dermatomes? Well, if they've lost any kind of sensation or there's a central nervous system issue, maybe they've got numbness, I can test. So let me pull up a little. No images. Nerve sensitivity test tool. And these are all giving me, nope. This is the one. So to test nerve sensitivity, you get a little instrument like this. And trust me, they look way scarier than they are. They're like this big. They're not that big. And the whole point is you don't put any pressure on them. You just roll them across the skin. Imagine for a moment what that thing would feel like, just rolling across the skin. No pressure, but like you'd certainly feel it, right? There's no mistaking this like spiny, sharp little crawling sensation as this thing rolls across your skin. So if my client is telling me I have numbness here on my leg, I say, cool. I whip out this little tool and I say, how does this feel? I say, nope, I feel that. So I move my tool a little bit. I say, how does that feel? Nope, I feel that. So I come around again and I say, how does that feel? Ooh, I can't feel that one. So where on the ankle did they lose sensation? Because if I know where they lost sensation, this dermatome is innervated by S1. S1 is in the sacrum. So when I add on my nerves, where is S1? They would be coming out of there. Make sense? Let me put it to you another way. Dermatome's practical importance to a massage therapist is that they can help us diagnose where along the spine the nerve issue is occurring. Because whatever nerve is being impaired they will lose sensation in the corresponding dermatome. So if the damage is at, let's say, T1, they will lose sensation in that T1 dermatome, not C6, not T4, not C7, T1. And when you roll your little tool across your client's skin, they will tell you, I feel it, I feel it, I feel it, I don't feel it, I feel it, I feel it. And you'll see this little bit of space where they're losing sensation. If they're losing sensation along their arms, it's probably something in the neck. If they're losing sensation in the hips, legs, and feet, it's generally going to be coming from the lumbar and sacral area. But this would allow me to identify precisely which junction, which spinal nerve segment. When I take the bones out, you'll see spinal nerves, each of those little pullouts, those sit in between a bone. They are numbered, they're regular, we know exactly where they are. Also, every nerve coming out of one of those little roots, they go to the same place on everyone. They're very predictable. Everybody is the same. So, dermatomes are very important for us to help determine where along the spine some nerve obstruction is happening. They will lose sensation in the corresponding dermatome. I feel like I've beat that dead horse. So, all right, dermatome, sensory receptors. Sensory receptors are a category of nerve endings. They will respond to a variety of things: touch, pain, pressure, temperature. They will vary in quantity from region to region. So certain parts of your body are more sensitive to certain kinds of stimuli. For example, the bottoms of your feet are usually not very sensitive to firm pressure because they hold your body weight. They experience firm pressure all the time. So you don't really notice it. You know what the bottoms of your feet are really sensitive to, though? Light pressure. Anyone ticklish on the bottom of their feet? I mean, that's what's going on. I'll give you another example. Temperature. The palms of the hands and the lips are extremely sensitive to temperature. So when your kid tells you they're running a temperature, oh, I think I'm running a fever, what do? You touch them with your hand. Or mom, you bring your little baby in, you give them a kiss on your forehead, and your lips feel how warm his forehead is. And you're like, yeah, dude, you're running a fever, kiddo. The distribution of these nerve endings. Oh, Lord, that's a whole video. I don't want to watch a whole video, but it's a homunculus. Let me just pull up a picture. A homunculus, there he is. Proportionate to the amount of sensory nerve endings in the body, this is what you look like. You have super large hands because your hands are full of sensory nerve receptors, full of them. Notice we also have really big lips. Any experience with an infant will tell you anything that goes in the hand, it goes right in the mouth because they get a lot of information about objects by putting it in their mouth. Texture, temperature, all kinds of stuff. You also notice that we have a lot of sensory receptors in the feet because we need to know what's going on with the ground that we're in contact with, as well as genitals for obvious purposes. So when we look at this homunculus, what's the purpose? What are we really seeing here? Humans are most sensitive, meaning we have more sensory nerve endings in our lips, hands, feet, and genitals. We are less sensitive and thereby have fewer sensory nerve endings in all of the other parts of our body. Another thing you will often see is a homunculus map like this. The parietal lobe of the brain is where all sensory information is integrated and understood. And the parts of the brain are very specific about what body part they are detecting for. So if you start at the 9 o'clock position here, You see the one that says the tongue? The right side of everyone's tongue is sensed right there. That is what that part of the brain does for everyone. The left part of the tongue is situated on the right side, because one side of the brain senses and controls the opposite side of the body. Don't ask why, I'm just reporting the news. It is what it is. One side of the brain controls the opposite side of the body. It's just a fact. But here is the general layout. The somatosensory cortex, somato or soma, any word with that soma or somat or somato, that means body. Sensory is sensory. So the somatosensory cortex is the body sensing cortex. That's the part of the brain that is being reported to. What is the body doing? Where is the body in space? What joints are being flexed or extended? What muscles are being contracted or stretched? This is where the brain gets its information as to what the body is doing. The motor cortex, motor means command. This is the part of the brain that is commanding movement. This is where the order to contract a muscle comes from. And as you can see, which part of the body needs to be controlled is very discreetly set in the brain. It doesn't matter how much you learn or what skills you develop. This doesn't change. This is set in human brain physiology. Cool. That was a fun little aside. So, last thing, and we'll take a break. The nerve supply to the skin, we have autonomic nerves going into the skin. Remember, autonomic means automatic. It's just, you don't have control over it. It's just plugged into the brain. We get sympathetic and parasympathetic fibers. So we have sympathetic is Spider-Man. That's your fight or flight mode, the stress mode. Parasympathetic is the Peter Parker system. That's the relaxation system, the rest and digest system. People think about these two as if they're mortal enemies and like it's one or the other. I would suggest to you, it's more like the accelerator and brake pedal on your car. You need both to function. Sometimes you got to get up and go. Sometimes you need to bring it to a stop. Both are important. Problem is when you put the pedal to the floor and you never let off, right? Too much stress leads you down a certain path. You got to be able to unplug and activate the parasympathetic division and calm everything down, rest and digest, hit the brakes. Sympathetic fibers. Sympathetic is Spider-Man. Think gas pedal, think stress, think a bear jumps out at me at the woods. What happens next? Sympathetic fibers cause vasoconstriction. Blood vessels get smaller. Those are the blood vessels in the trunk. So we shunt blood away from the core and outwards to the skeletal muscles because I have to run away from a bear. I don't have time to be digesting my lunch. I'm probably going to drop my lunch and run away from the bear. Vasoconstriction shuts blood away from the core organs and out to the skeletal muscles. This also stimulates sweat glands and erector pili muscles. So we start sweating and we get goosebumps. Those are all very stimulating things. Those are gas pedal things. Those are sympathetic division. Cool. So we've covered everything on this slide. Everybody feel good so far? Feeling good in the neighborhood? All right, let's take a quick break. Let's take 10 minutes. We'll come back. We'll pick up right where we left off. All right, guys, we are back. Everybody's nice and refreshed after the break. All right, so we last covered nerve supply to the skin. We talked about autonomic nerves, which would be both from the sympathetic division and the parasympathetic division. We talked about sensory receptors and how they respond to the various stimuli, and we can vary in quantity from region to region. We see that variation in the representation of the homunculus. So the large hands and large lips are meant to show you've got a lot of nerve endings in those areas, not as much in areas like the back or in the legs. We also talked about dermatomes, and despite my saying how unimportant they are, we do use them in massage occasionally to help narrow down where damage to the spinal cord or impingement of a spinal nerve, where that nerve origin is, so that we can better treat whatever condition it is that we're presented with. Next, we'll talk about the role of skin in temperature control. And I've already kind of touched on this a little bit in the beginning of class today. We know that normal temperature for a human is 98.6 degrees Fahrenheit or 37 degrees Celsius. And I know we don't do a lot of metric system in the United States, but I have seen that question on MBLEXs before. So I highly recommend you know the Celsius rating for normal body temperature. It's 37 degrees Celsius. That is definitely one that I would know for sure. 37 degrees C, 98.6 Fahrenheit. Various ways that the skin helps us retain temperature control. Most important is going to be blood flow. Bringing more blood to an area will increase its temperature because blood's hot. Restricting blood flow to an area will lower its temperature. So this will be regulated by the autonomic nervous system, the brake and the gas pedal working together. This is the most important control mechanism because this is the one that will affect it the most. If we increase blood flow to the skin, meaning we bring more blood right to the surface, a lot of that heat is going to get lost out in the atmosphere. So increasing blood flow to the skin increases heat loss. This is why when you're really hot, your skin is flushed red. All that super hot blood is pushed out to the surface, so you start dumping off all the excess heat into the atmosphere. In the event that we are getting too cold, vasoconstriction engages, we restrict blood vessels going out to the skin, so the skin gets less blood. Therefore, we lose less heat through the skin. This is why when you're really cold, lips and fingertips turn blue. Is not blue because you're cold, is blue because there's very little blood running through it. Another way that we are able to get rid of excess heat is through sweating. And I feel like I've already talked about this one at length, throwing in the extra examples about dogs don't sweat, they pant. But about 27% of your heat loss is done through sweat. So very critical component. And lastly would be the erector pili muscles. That word is misspelled here on the slide. It is spelled E-R-E, erector pili. That is incorrect. It is A-R-E, erector pili. I don't know why they're misspelled, but it is erector pili muscle. We talked about those as well. When they rise up, they pull up on the bottom of the hair follicle, causing the entire hair to raise a little bit more. That's a goosebump. That's a goosebump. So when they cause hair to rise, it traps a layer of air between the hair and the skin. So this layer of air gets warmed and serves to insulate the body. Cool. Moving swiftly along. Next, we come to glands of the skin. Glands are always going to be organs that produce or secrete some kind of fluid. Usually, the fluid in a gland is going to be a hormone. That's 9 out of 10 when you talk about glands. We're talking about endocrine glands. We're talking about pancreas, or we're talking about adrenal glands, or something along those lines. However, since we're in the skin, there are 2 primary glands that we deal with in the skin. These are sweat glands and sebaceous glands, sweat and oil. Sweat glands come in two flavors, apocrine and epicrine. More on those in a moment. Just more broadly though, sweat is by and large water, 99% water. The remaining 1% would be salt, nutrients, and waste product. And something important that I would like to talk about since we're here. Sweat does not stink. Nope. What stinks is sweat contains salt, nutrients, and waste products. Those nutrients that are being excreted onto the surface are eaten by the bacteria that live on your skin. And you know just as well as I do, when you eat something, you poop. So when all this bacteria on your skin consumes those nutrients in the sweat, they poop right on your skin. And poop stinks. That's BO. That's BO. It's not the sweat that stinks. It's the bacterial poop from all those bacteria that ate your sweat. That stinks. So if you want to conduct a fun little experiment, and this would be better if you lived alone, but go for a few days without a shower and you start to go a little ripe. Take a shower, right? Nice, good soap, good scrub, and all the really stinky bits, and then go work out. And when you start with nice, clean skin, when you come back from the gym, the BO is not as bad because there are fewer bacteria and fewer piles of poop sitting on the surface of the skin. Again, sorry to gross you out, not trying to make you feel weird. I'm just reporting the news. So sweat is mostly water, 99% water, 1% salt, nutrients, waste product. We talked already about their function. It reduces body temperature. That's the whole point of sweating. Lower the body temperature. And yes, there's an excretory function as well. But when you're talking about 1% of an excretory function, that's like a footnote. The real function here is temperature, heat loss. You're trying to lower body temperature. Sweat is used to just discharge other secretions onto the surface, like oil. And its low pH inhibits microorganism growth. So sweat is slightly acidic, and the whole point is we're trying to reduce the amount of bacteria that's present. Now, low pH inhibits, it doesn't prevent, it just keeps it from getting out of control, but it doesn't stop bacterial growth. It just puts a cap on it. Now your sebaceous glands, the oil glands, secrete sebum or oil onto hair follicles and onto the skin. The purpose of this is to lubricate as well as prevent evaporation. Remember, oil and water do not mix. So if I slather a layer of oil on top, water can't get through it. So I've effectively sealed the water inside. It functions pretty much the same way Vaseline functions. You ever put Vaseline on a light cut or an abrasion, and it seals that cut. So junk can't get in, but also so the good stuff can't get out. And that's the whole point of sebum. It's also antimicrobial. So it's also trying to aid in keeping our bacterial populations in check. Ooh, so before we jump in even more, I want to talk a little bit more about the two kinds of sweat glands. We have, let me go back to my notes. Sebaceous glands give you oil, and then sweat glands, the medical term for them, are sudoriferous glands. Sudoriferous glands. And the way I remember this word, they're odoriferous glands because they're sweat glands and they stink, even though sweat doesn't stink. So the two flavors of sudoriferous glands, we have apocrine and epicrine. And just once, I would like things to be named in a way in medicine that don't sound exactly alike. So apocrine and epicrine glands. Now, I'm going to level with you guys. I have to do a quick Google search just to remind myself which one is which. Sorry, I'm a human. I can only hold so much in my noggin. Okay. Eccrine glands occur over almost all your body. So, you know, like back sweat, arm sweat, leg sweat, that's eccrine. Apocrine glands open into a hair follicle. So they are associated with hair follicles. Now, critical thinking time, guys. If apocrine glands are associated with hair follicles, where would you think we would see proportionately higher numbers of apocrine glands than eccrine glands? Head. What else? Underarms. One more. Genitals. So guys, also consider, where does the BO get worse? Head, pits, crotch. So apocrine glands, those are the BO glands. They are more prominent in hairier areas. Head, I won't say armpit, I'll say underarm or axilla. And in the groin, in the genital region. Epicrine, and actually I mispronounced eccrine. Eccrine glands regular skin sweat. You go to the gym, you work out, I've got sweat beading on my arms. But that sweat doesn't really smell. Sweat doesn't smell. But all that hair in the axillary region holds a lot of bacteria, and a lot of bacteria are pooping. That's why the pits stink. That's why your junk stinks. That's why your head stinks when you don't wash your hair. Apocrine versus eccrine. They are both sweat glands, but apocrines are associated with hair follicles. So those are the ones that are most associated with body odor. Fun stuff today. All right, next, moving on, we get to mammary glands. So only the illustrious half of our population is replete with mammary glands, women. Men do have mammary glands. However, it is just 4 orders of magnitude less than the number of mammary glands that women have, okay? Men do have mammary glands. They are associated with the nipple. They exist for us just like they do for you, except for men, you're usually talking about several dozen. For women, you're talking about several dozen thousand. It's an order of magnitude difference in the amount of numbers. But, and again, I don't want to gross you guys out too much, but this is anatomy, and anatomy is a little bit gross, let's be honest. Men can lactate. Men can produce breast milk. Number one, it's nowhere near the volume of breast milk that women will create. And number two, it is not guaranteed that every man will produce breast milk. We are just capable anatomically of doing it. Whether or not we physiologically will do it or not is a separate question. But men can lactate. Mammary glands are modified sweat glands. So nature just took the same basic tool. We've already developed how to sweat. Now what we do is add more stuff to those glands. Particularly, we have glands that are producing the sweat. That's the base of the milk. But then they're also pulling nutrients and antibodies and things like that out of the blood and mixing that into the sweat. And we're also carrying certain types of sugar, particularly lactose. So lactose, that's the milk found in sugar. So I'm sorry, the sugar found in milk. So mammary glands are just sweat glands. They just enrich the sweat with nutrients, with antibodies and other kinds of immune system players, and sugar in the form of lactose. That is what milk is. It's fatty sweat. Kind of makes you never want to drink cow's milk ever again. Cool. Another important, though less known gland are the cerumen, or the ceruminous glands. They make earwax. They're only found in one place. It's in the ears. Oh, ceruminous glands produce cerumen. Cerumen is the medical name for earwax. Just making that connection real quick. Cool. Cerumen is earwax. Ceruminous glands make the earwax. Before I move on, I want to check my anatomy app and see if it does anything for breast tissue, and we will be learning together because my app just added a female model. The whole time I've had this, they've only had a dude. Now they finally have a female. So there's a skeleton. Oh, that's definitely a female skeleton. Look at those hips. Look at that skull. Yes, yes, yes. Ah. Beautiful. So not to be too gross, but there's our female figure. We take away skin and we're left with the breast fat tissue. It's just fat. But I'm going to go one layer deeper. There are the mammary glands. So notice how they are spread throughout the breast tissue, but all of their tubes are leading to the same spot. I'll give you one guess where that spot is. So we have all of these glands constantly filtering water from the blood plasma. And then now that they've got water, they will add fat and sugar and antibodies and stuff to it. And bibbity bobbity boo, you've got milk. That's cool. I haven't actually seen this one before. So that's pretty cool. All right. Moving right along. Hair. Hair itself is made of dead keratinized cells. So hair is dead. There is only one part of hair that is alive, and that is the hair root. So, and I know this goes way beyond us, but hair growth goes in 3 phases: anagen, telogen, anagen phase, telogen phase, and one more, I forget off the top of my head. But hair grows and then it stops. Hair follicles usually contain more than one hair, especially on the top of your head. So one hair could be grow in the active growth phase. The others in the same follicle are not actively growing. This is why, ladies, you ever waxed your legs and not much longer those hairs start sprouting up again? It's because they were in their dormant phase when you got the wax. You waxed the hairs that were actively growing. They're gone. But now another hair becomes actively growing. So just a few weeks after you've waxed, you've got new hairs growing up. Those are the ones that are now entering their growth phase. So what do? You wax them. And then short time later, the next batch of hair enters its growth phase. So you get another batch of hair that starts to grow up, and then we wax that. So if we keep waxing over and over and over again, right? I mean, you give it weeks, but when you keep waxing, eventually you get all the hairs that have been ripped out. So they have to all be regrown, which means they're now all on the same growth cycle. And that is ultimately the goal with long-term waxing. You want to do one wax, all the hair's gone, and it stays gone for weeks at a time before it starts to grow back. But it takes a while to get there because all of your hair is not in the same growth phase. part of the long-term strategy with good waxers is you're trying to get it all on the same growth cycle, so all the hair grows and you wax it all at once. That's outside our scope. Massage therapists don't do hair removal. But I also am a licensed esthetician in Florida, so I did a lot of waxing. So what's the point of hair? Why do we even have hair anyway? Well, we got to protect from UV radiation, because the one place the sun is guaranteed to hit you is on the top of your head. So all this hair helps break up some of that sunlight so we don't absorb as much UV radiation. It also kind of helps protect from trauma, especially you ladies, the really big ornate hairdos, you know, it gives a little bit of a cushion. It also provides insulation, as all hair does, right? It holds air really close to the scalp. Your body warmth heats up that air. So we got a nice warm layer held close to the skin. It also protects ports of entry from large particles. So this is why we have nose hair and ear hair, right? As you breathe in all the particulates that are in the air, dust, pollen, dander, bits of debris, the idea is the hair filters all that stuff out, so it doesn't end up back in the nasal cavity. That should be relatively pure air, which then gets brought down into the lungs. Same thing with the ears. You don't want foreign dust and material building up in the ear. That could occlude the ear canal, or more extreme, it could damage or puncture the eardrum. So we want lots of protection. That's why we put lots of hair inside the ear canal, just to prevent larger particulate matter from making its way too deep into the ear canal. And they're also connected to nerves, and this nerve plexus that's connected to all of the hairs detect very small movement of the skin. This is how you're able to feel a breeze in the arm hair, or I don't want to go, that's a bit of a stretch. I won't go quite that far. But the nervous system is able to detect the movement of the hair as something touches it, or as that wind brushes against it. So as the hair moves in relation to the follicle, that movement is translated to the nerve underneath, and the brain is informed that the hair has been moved. So the brain understands wind is blowing, or someone barely grazed me, like just enough to touch my arm hair. Now, nails, as we talked about, are also made of dead keratinized cells, but keratin can be arranged in a couple of different ways. With hair, you're talking about long strands of keratin, right? The strand form. With nails, you're talking about a broad plate form that grows kind of in that form. The entire nail that you see is dead. The only part of the nail that is alive is the nail bed, and that is completely covered by skin. So the growing part of the nail, I'm trying to flip you guys off, but the growing part of the nail is actually under here. All of the stuff that you see, that's all dead, all dead. And so there are a few like technical vocabulary terms that we would learn. If you have one of the little colored dots, right, the little half moon deal at the base of your finger, that's called a lunula. It's from the root word luna, meaning moon. So it's a little moon-like projection. Some people have them, some people do not. I get them on my thumbs, but I don't have them on the rest of my fingers. Some people have very pronounced lunulas on all of their fingers. It's just a genetic variation. It doesn't really make a difference in terms of nail growth or development. Just some people find them more attractive or less attractive. I don't know. Next, you have what's called the lateral nail fold. And that's just the corner, the little corners of the nails. A corner right there, lateral fold, corner right there, lateral fold. Then you get to the nail. That is the body of the nail. That is what you're putting your nail polish on, right? The body of the nail. Then you get to the end, and now you have what is known as the free edge. The free edge is the nail that you're scratching with. It's the white bit at the tip. The free edge, when you think about like a French manicure, That's what you're accentuating. You're accentuating the free edge, right? You've got the pink base of the French manicure and then the white tip. That white tip, that's the free edge. The nail matrix is under there as well. That's the part that's actively growing new nail. You've got the nail root, proximal nail fold, cuticle. Cuticle is the little bit, and I don't think I can really zoom in well enough, but the cuticle is this line of skin. You can push it back with your cuticle pusher, right? Like, ooh, I don't even have my nail tools on me, y'all. But when you push back the cuticle, you end up with a nice solid skin ridge like that. Like that. And any nail tech will tell you, don't cut the cuticle, push it, moisturize it, but don't cut it. If you cut the cuticle, it will bleed and you're now open to infection. Don't do that. Push it, moisturize it. And if moisturizing isn't enough, get you some cuticle oil. That'll do the trick. My advice to you. That's free. Free nail advice. There you go. All right. The nail bed is the soft bit of tissue that sits underneath the nail. So again, not to freak anybody out, but if we were to just pinch the nail and yank it off, there is a wet, pink, fleshy, super duper sensitive, do not rip off your fingernails, but there's like a wet, gushy bit under that. That's the nail bed. It's nourishing, and that's all. Hyponychium. Yeah, I think we've covered all we really need to cover about nails. They protect the tips of the finger and toes because the bones that are under there are really small and delicate. So you want a nice little hard plate over that super tiny sensitive little bone. The bone of your thumb is actually going to be like half the size of your thumb. It's just, there's a lot of flesh built up in there. It's just, they're not very big. Okay, so as we age, skin is the organ that most readily shows the signs of aging. You don't notice an aging liver or an aging heart, usually until it's too late. But boy, you notice the aging of the skin by your mid-20s, 30s at the latest. The first thing we start to notice is the epidermis begins to become thinner. Thinner skin is going to be more prone to injury and infection because it's thinner, and it slows healing. Fewer Langerhans cells, those are your immune cells. Fewer immune cells means greater risk of infection. There's also a decrease in the glandular secretions. So your glands stop producing over time. You don't produce as much sweat, nor do you produce as much sebum. The overall effect is that the skin begins to dry out. This will also increase the chance of infection. Because the skin has now become compromised with age, it is also producing less vitamin D. That will lead to fragile bones. Because remember, vitamin D is needed to bind calcium for the bone matrix. So if I don't have vitamin D, I can't put calcium in the bones, ergo, bones get weaker. The ground substance, the fluid part of the skin starts to dry out as well. So you guys are all young and healthy, and like you look at your skin and you push on it and you're like, oh, it's so plump, and it just bounces right back. When I take my finger off, it just bloop right back where I took it. Or you pinch a little skin off your knuckle and you lift it up and you let it go and it just drops nice and flat, nice and tight like it's supposed to. Young skin. Enjoy it while it lasts, because at a certain point, your body will decrease its production of elastin. It will also start to decrease its production of collagen. This will make the skin weaker. That's collagen, that gives it strength. And it makes it less resilient. That's the elastic property. Remember, elasticity doesn't mean it stretches. It means it bounces back, right? It snaps back. So less elastin means the skin doesn't bounce back anymore. And so when you do something that pulls on the skin like this, with less elastin, when you let it go, that little bit of skin doesn't just fall down. it takes its time, slowly resettling. Remember, guys, your skin is receiving a pull all the time from gravity. It's pulling you down. So think about what we see as we age. As the skin loses collagen and it loses elastin, the skin begins to sag. We start to see the wrinkling, right? The little turkey waddle, right? As the skin starts to sag, it's responding to the pull of gravity. And with less collagen, the skin isn't as strong and it starts to wrinkle. So particularly the deeper wrinkles, like the forehead wrinkles, crow's feet, and laugh lines. Those are the ones we start to see more. Pro tip, skin damage, our skin ages more readily when it's been damaged, particularly in the sun. So you can really tell the people that don't wear their sunblock, and you can start to tell in their 30s. So they start to get hyperpigmentation spots. They start to develop premature wrinkling. They start to develop thickening of the skin. Have you guys ever seen the picture of that truck driver? He was a truck driver. So driving, one half of his face got a lot of sunlight and the other half didn't. I'm seeing some nods. I want to pull this up. Truck driver face skin. Yeah, that'll do it. So this was the guy. He spent half his life driving a truck. And so the driver's side of his face suffered long-term, prolonged skin damage from so much sunlight. The other half didn't. So the other half doesn't look so bad. But this is the effect of sun damage. Thickening of the skin, deepening of the wrinkles, more hyperpigmentation, so those liver spots, dark spots, and just an all-around, like, more sagging of the skin, right? Like, look at down here, look at the jowls. On one side, it's like sagging and wrinkled, but on the other side, it looks a little more pulled tight. It's a little more taut. This is classic sun damage to the skin. This is what you see when you look at the skin under a woods lamp, which shows UV skin damage. So all of those little spots, that's hyperpigmentation. And eventually you'll be able to see those without the woods lamp. They just show up on the skin. Hyperpigmentation, sometimes you'll hear them called liver spots, but it looks like that. The dark kind of pigmented spots.
Why are they referred to as liver spots?
Because they're the color of a liver. They're kind of brown. That's all. One thing I would like to say, hyperpigmentation, we are not talking about freckles. That's not what we're talking about. So if you wake up in the morning and you have a face that looks like this, and you have always had a face that looks like this, we are not talking about hyperpigmentation. What we are talking about are spots that appear and develop over time, not just the normal way your skin was born. Freckles are normal. Hyperpigmentation is not normal. There's another example of hyperpigmentation, particularly right here through this cheek area, right? And then spreading a little onto the side of the nose. That's hyperpigmentation. Yep. Sun damage. And yes, I will say it out loud, even darker skinned individuals can get sunburn. They still get sun damage. It takes more sunlight for longer periods of time to damage their skin. But no one is immune to sun damage. It doesn't matter how dark your skin is. You can still develop all of these same kinds of skin problems. Black people can get skin cancer. The numbers between Black people and white people for skin cancer are not the same, but they do get skin cancer. I just want to make that clear. They're not immune to it because they have darker skin somehow. Their numbers are far lower for sure, far lower. Okay, so as the skin ages, the ground substance dehydrates, so the skin becomes drier. This causes wrinkles, this causes sagging. And also, all new development slows down as you age. So new hair, new nails, they all grow more slowly. So next we'll start talking about the effects of massage on the skin. Massage has numerous effects on the skin. First, we can talk about superficial reflex techniques, techniques that relax muscles through reflex actions. And these would be reducing anxiety, producing sedative effects, reducing pain. I can think of one good example of this, but actually I don't really think that's more of a skin thing. I think it's more of a nerve thing. I think it's more of a nerve thing. I'll explain it anyway. You make up your own mind. There is a technique called plexing. And the way it works is this. You have nerve clusters of nerve endings spaced throughout the body. And when you put pressure on them, they hurt. But when you put pressure on them, the way the brain responds to that pain is by releasing natural endorphins, natural painkillers. So, and one of the really good examples is this nerve cluster right behind your ear. So right behind the earlobe, press your finger in, there's a little depression. Your fingertip fits very nicely right behind the ear. Now, nice and careful, guys, push on it. And you quickly realize, that does not feel good. There's a nerve cluster right there. And putting pressure on the nerve cluster hurts. That's common to all nerves. Nerves do not like to be touched, or poked, or pressed, or compressed, or impinged, or prodded, or have any kind of pressure put on them at all. If you do, it hurts. But instead of pushing on it, if you instead tap on it. Now, I need a nice solid tap. I'm going to tap my finger on my desk to kind of give you a sense of what pressure I'm talking about here. Meaning we're not like, ooh, tappy, tappy. I need a stiff finger right in the spot, a pretty solid tap. Now, tap it for several seconds and really like check into your body. You should feel within the next 10 seconds, just kind of this wave starting up in the head and kind of rolling its way down, just this like this wave of relaxation. What you're feeling is the release of endorphins through the stimulation of this nerve plexus. And this is a trick that I used all the time when I was waiting tables. Anybody waited tables before? Super easy job, right? Anyone could do it. Super freaking stressful all the freaking time, always running around, like you're always behind. Welcome to the life. So as I'm like zipping around the dining room and running around the kitchen and doing all that stuff, I'm just like a crazy person. But it helps calm the body by naturally releasing endorphins. It helps lower the blood pressure. It helps calm the body. And it's a technique that I use a lot in my own life. Just when you need to kind of take the edge off, right? It's like a little free natural painkiller. And who doesn't like a free Vicodin every now and then? Am I right, guys? Am I right? It's a very safe technique, right? There's no damage. As long as you're not like going crazy. It's a very safe, very effective way of releasing natural endorphins, promotes stress relief, decreases anxiety, and just feels good. So moving on. That was my superficial reflex technique, by the way. That's the one I'm showing you. I'm not going to talk about reflexology. Moving on, we'll talk about superficial fluid techniques. So superficial massage on the skin encourages the fluids to move around. By fluids, I'm really aiming at blood and lymph. That's really what we're aiming at. So we learned way back in like massage fundamentals, like Swedish 101, our firm massage strokes always go up the limb, right? We always push blood back to the heart. That is because the heart is actively pumping away from the heart. There is no pump once you get down to the feet. The massage therapist needs to then push all that blood back up to the heart. So all of our firmer pressured strokes are all centripetal strokes. They all go up the limbs, returning to the heart. That's exactly what we're talking about right here. We are helping the skin by increasing venous return to the heart. The other one would be lymph flow. We talked week 5, I believe, like 2 weeks ago, about lymphatic vessels and that they're superficial to the skin, or right under the skin. They're very superficial. They're not usually deep in the arm. So it takes very light pressure to stimulate lymphatic vessels. This is good for edema. So any kind of fluid swelling going on, lymphatic drainage is the indicated modality. Edema is a fluid swelling. Notice when you look at those ankles, that's not inflammation. That is just swelling. Remember, inflammation, swelling, redness, heat, and pain. It's not super red, it's not painful, and it's not super hot. Actually, usually with edema, when you touch it, it's cold. That's not inflammation. That is fluid swelling, that is edema, and for that, we do manual lymphatic drainage. Cool. Now, since we have to use light pressure in order to activate the lymph flow, what we're effectively doing then is using light pressure as effleurage. We're stroking, gentle stroking. And I defy you to find me a person who does not find gentle stroking to be very effective, or very relaxing. So this induces a relaxation response as we are engaging in these superficial fluid techniques. Now, as we work deeper tissues, for example, with neuromuscular, where we're really aiming through the skin to get down to the muscle below, neuromuscular techniques will still play a role on the skin. It reduces muscle tension and reduces trigger point activity. And when you're done, it increases blood flow to that area. When you increase blood flow to some muscle under the skin, you are still increasing blood flow to the skin over that muscle. You can't do one without the other. You bring blood to an area, it goes everywhere in that area. Muscle, skin, bone, organ, all of it. Connective tissue techniques use reactive hyperemia to increase blood flow. What we're usually getting at here are things like structural integration techniques, or just more simply, things like friction, right? You've done enough friction strokes in your day, right? You push and take the skin along with you for the ride. And you do that long enough, the skin turns red. That redness is an influx of blood known as hyperemia. And this is what we can, this is one of the techniques that we can use to try to reduce muscle adhesions or to realign collagen fibers. For example, if we're doing scar tissue massage. Passive movements also aid in the flow of blood and thereby aid in the functioning of the skin. This works on muscles and joints, and it produces sedation through a reflex response. It's very relaxing to have your limbs moved for you, right? When you really truly can let the full weight of your arm or leg kind of sink into your therapist's hands, and they are very stable, right? And they're very controlled, so you feel very safe giving them your leg, and they move it around according to its normal range of motion. It's very, very relaxing. But as you bring that leg up, right, just like you see in the picture, we've changed the orientation of the leg. So by holding it that way, now the blood follows gravity. The blood in the veins is pulled down from the knee into the hip. So by moving the leg around, we are increasing the venous return of blood. Also effective to the skin are a variety of percussive techniques, especially if you need to increase blood flow. Percussion strokes and compression strokes are the most effective at encouraging blood flow into a particular area. We have clapping. I don't use the word clapping, I say slapping, is done with a flat hand, right? Tapping, done with the fingertips. Think about like playing piano, but play piano on your face. Right, we go around the eyes, very stimulating. Go around the eyes, we go along the jawline, we go up along the maxilla. It's very relaxing. And beating. Beating is done with a loose fist. Loose fist, not a curled up fist, loose fist. And the trick with beating is not to focus on the fist at all, The trick is it's all in the wrist. You're not hitting them so much as with a nice loose wrist, you're slapping them with the side of a loose closed fist. Alternating blows depress and release the tissue. Alternating blows, we mean 1, 2, 1, 2, 1, 2. Depress and release. As opposed to blows in unison. Boom, boom, boom. The stimulation that you trigger will vary based on your rate. So you would imagine this would not be as stimulating as this. So the quicker the rate, the more stimulating the tapotement will be. How vigorously are you applying tapotement? Because again, tapping is one thing, beating is another. And the duration. Duration is important. Short term tapotement is stimulating, right? If you take your thigh and you beat on your thigh for just a few seconds, that leg starts to feel very tingly, very stimulated. But if you have the stamina and you can keep that tapotement going for like a minute or 2 minutes or 3 minutes, you realize the leg does not feel nice and tingly and stimulated. It actually starts to feel kind of dead and kind of numb and very, very inhibited. So tapotement can be a stimulating stroke when it's done in the short term, but it can be a very sedating stroke when it's done for a longer term, talking on the order of several minutes. Good stuff? Cool. You guys are such an easy class. I just sit on, I come online and I talk, and then we go home. All right, last slide, my friends, last slide. The effects of massage on the skin. We'll talk about heat, cold, and hydrotherapy. When you apply heat to the skin, your body wants to suck up all of that heat. So when you put heat on the skin, it causes vasodilation. Those blood vessels get larger to bring more blood to the surface so they can absorb the heat and then burrow back into the body and distribute that heat. Putting heat onto a muscle relaxes the muscle. I'm sure we've all known this firsthand, right? Heat on a muscle feels oh so good. It also stimulates circulation because remember, you put heat, we pull blood to the area, but blood circulation is one way. If you have pulled more blood to the area, that blood has to move on. When it moves on, it pulls more blood to the area. So by placing heat on the body, it stimulates that circulation, and since the blood is moving faster, it speeds the removal of waste. Pretty logical stuff. Cold will do kind of the opposite. When you put cold on the tissue, it causes vasoconstriction. And now we close off the blood vessels to keep the blood vessels away from the cold. We're trying to preserve our core body temperature here now. This will also reduce edema, and it will have an analgesic effect. The word analgesic, an means without. Algia is a pain condition. So analgesia is a without pain condition. It's a pain reliever. So any kind of like analgesic cream is a pain relieving cream. It's creating a without pain condition. Subsequently, so you put the cold on, it's super cold, all your vessels constrict, edema goes away, pain goes away, and then you take the cold off. Blood vessels dilate, right? Subsequent vasodilation, because now we are pulling blood to re-warm that previously cooled area, warmth and relaxation at last. And hydrotherapy is very effective on the skin, probably most directly effective on the skin since it's in direct contact. The one that I recommend most often is always contrast therapy. Are we familiar with contrast therapy? That's the alternating heat and cold. Yeah, so when you're doing contrast therapy, the important bit is you always bookend with cold. So you start with cold, and then you put on heat, and then cold and heat and cold and heat and cold, and you end with cold. Start and end with cold, because the idea is you want to finish the body constricting all those blood vessels. You want to seal it off from the work that you've just done, right? You've increased circulation, you got all those nutrients brought in, all the waste products brought out. Now that you've cleaned it all up, close it down. Finish and start with cold. And this will work for whatever kind of hydrotherapy you're doing. In the picture here, we're looking at full body submersion, but this could also be talking about hot and cold packs, hot and cold towels. This could be a table warmer. This could be ice massage, whatever form of hydrotherapy you're using. When we're using contrast therapy, alternating heat and cold, we always start and end with cold. Good stuff. All right. So this is the last slide for the day. I will open it up now, guys. Any questions over anything we have covered so far? While you're thinking, I will just carefully scroll back through, see if anything triggers. We covered a lot today. But the good news is skin is not that complicated. Wait till you get to the nervous system. Oh boy, you're gonna wish you could go back to integumentary. All right, if that didn't spark any questions, I will say, make sure that you know, nope, wrong one. All right, I would say for certain, make sure you know the layers of the skin: dermis, hypodermis, epidermis. Make sure you know what structures are located within the dermis and what they do. So what is a sebaceous gland? What is an epicrine gland? What is an erector pili muscle? Also, know the 5 layers of the epidermis. George spit gravy in Lucy's corn: germinativum, spinosum, granulosum, lucidum, and corneum. I would also make sure that you are familiar with all of the glands that we have talked about: mammary glands, sebaceous glands, cerumen glands, all the glands. Okay. All right, last call. Questions, comments, concerns? All right, my friends, if you have any questions, please feel free to reach out to me. I'm always happy to answer questions. Otherwise, I would say you guys have a wonderful weekend, be safe, and I will see you all next Thursday. Don't forget to do the quiz on Moodle. All right, have a good night, everybody.